Hello, and welcome to another episode of Chew Your Food. Today, we have a segment called Learning on the Job, where we ask three main questions. What are the requirements? What's a day in your shoes like? And what keeps you motivated to keep coming back? This is your host, Mr. L. I had the chance to interview a scientist who specializes in gene therapy. We spoke about the beginning of his educational journey and how good grades allowed him to start a track towards medicine. Special thanks to Mr. L's tutoring and enrichment, education beyond the classroom, where the passion for teaching meets the science of behavior, tutoring students K-8 in science and math, tutoring in a group or one-on-one setting with in-person and Zoom tutoring available. Please check out our website, tutorwithmrl.com. Reach out today.
All of us, probably yourself, and definitely I got influenced for my career now by one of my teachers. Mm-hmm. So even if these kids now, they don't get it, I don't know when, I didn't do high school here in the US, but when they start taking chemistry, then they will remember, periodic table. Mm-hmm. We learned about it a few years ago. Yeah. That's honestly, that's good enough for them.
You are a scientist in Massachusetts.
Correct.
And I really did want to find out, how did you get into the science field?
Sure.
How did you start your career?
So going back, my father was an engineer.
Okay, nice.
And everything that I wanted to do, I was watching him. Like he had like a small space at home to like fix TVs and radios, and so I was watching him.
Yeah.
And everything I wanted to do was to be an engineer at the time. But and then as I was finishing high school, and I grew up in Baghdad, Iraq. So as I was finishing high school, the computers became a thing. Mm-hmm. So it's like, I like computers. It still has an engineering concept to it. So I wanted to be a computer engineer.
Okay.
But finishing high school and like the system of education in some countries, obviously, the better grade of your GPA from high school, the better program you could get into. Gotcha. So medicine is the highest, pharmacy, dental school, and then engineering is low. Is that?
I didn't realize.
But I got good grades that I could go anywhere. I could go to medicine as well. Oh yeah. And that's where the difficult part came. I was lucky that my parents never really forced me to do anything. Like they weren't after me. Oh, you have to go to be a doctor or anything. No.
Wow.
From like 18 years old, my father was like, "You do whatever you want. I'll tell you my opinion."
I love it.
But especially in like third world countries, engineering is not the best job. Oh. It's you don't get a good salary. People like my father had like 2 jobs to be able to like help a family.
I hear you.
So that's when the decision was like, okay, I could be an engineer, but then maybe I'm not going to have the best future.
And struggle, yeah.
And struggle. Mm-hmm. So I decided to go into medicine.
Okay.
And I was in medical school for a couple of years.
Wow.
But then because of the war, I left Iraq in 2008. Okay. And I spent 1 year in Syria where I studied English. And then I got to learn about a program that helps bring Iraqi student refugees who are displaced by war from Syria to bring them to the U.S.
Okay.
And that's how I ended up coming here.
And what year was that when you came over to the U.S.?
2009, so almost 13 years ago, yeah.
Wow.
Like in the beginning, just like learning about the education system in the U.S. was obviously hard. For one, like medical school in Iraq was in English. We take English classes all of high school, which helped.
Nice.
But like for example, I was like, I'm gonna come to the US to study medicine. They're like, no, you have to do 4 years of college, and then you start into grad school or medical school.
Got you.
But like during college, I started to do all of the like taking like chemistry and biology classes,
right?
And then there was a lab part to these classes, and I've never been to a lab before.
Okay.
And then I started to get into research, and one of my chemistry professors who influenced me to this day, he was like, hey, like, why don't you come to work in my lab during your like a weekend or evenings? Just come work in my lab.
That's awesome.
I don't know what he saw in me, and I told him I don't like research. I want to go to medical school. He said, just come. That's okay.
Just see what it is.
Yeah.
First. Okay.
And sure enough, like it was obviously like fascinating to me in the beginning. Like you get to do all of these cool things and like you get to create something.
Yeah.
And then the part that I love the most to this day is troubleshooting. Like when something's not working.
You know what I'm hearing here is a lot of like, it reminds me of the story you're talking about of your dad just fixing stuff.
Yeah.
Like creating
exactly.
something with your hands and being like, hey, look, well, let's work with some more living things and see how that goes.
Because you make a calculation in your head, and if you have a good mentor, which is a key to any job, and especially if you want to decide about your future, like what you want to do after high school.
Yeah.
You sit down with your mentor and they tell you, hey, like this makes sense. But at the bench in the lab, it's not working. Well, why? Trace your steps back. And that's the thing that I loved. Yeah. So obviously for a while it was hard. I remember one time I was trying to do something and it was supposed to work right away, but it wasn't working.
Okay.
And I remember I went to his office and I told him, hey, like, I'm sorry, I think I'm done with this. I think this is as far as I could take it. Mm-hmm. But I was like, no, go to your class, take the next week off, don't come to the lab and come back after. And sure enough, that worked just like to make you disconnect. And we need that in any job, not just in science. Like you want someone to see you, hey, like, you know what? Let's take a step back. I think you're doing too much, because sometimes if you are angry or if you cannot think, you cannot focus. Yeah,
that's right.
So sure enough, like after like almost in my third year of undergrad, I was studying for the MCAT because I still was like thinking that I want to go to medical school. Right. And I remember I paid for the test. 3 days before the test, I canceled and I stopped. Okay. Because during that time, like the love of research was inside me, and I thought like maybe I should be a scientist and not a physician.
Nice. Okay.
So in between, like after finishing undergrad, I just took like a couple of years off, and I worked in a lab just to see if I actually like it. And I did, and I went to grad school, and I completed my PhD end of 2020. And I've been working. Man. Thank you. And I've been working in a biotech company doing gene therapy since then.
Okay, that is awesome, and that actually beautifully goes right into my next question. Yeah. Like, what is your day-to-day like? If it's not, it doesn't have to be. I know everybody's day changes every now and then, but walk me through like last Tuesday. Yeah. Like what was the day like for you last Tuesday? Like when you wake up.
Right. Yeah. So I think, science and research is a little bit different with your position and where you do the science or research. Gotcha. So if you do the science or research in a university or a hospital, your work is around the bench for the most part, especially at the entry level. For example, when I was doing my PhD at university, most of my time of the day was at the bench doing stuff in the lab. So like if I want to work with cells, or if I have work with animal models and I have to check them or process some samples, and it's a pure work in the lab. Yes, you have your meetings with your mentor once a week. If you have a collaboration, you meet with the collaborators to talk and decide and make a plan. Okay. Working in a pharma company or in a biotech company is a little bit different, where all of these companies are focused try to address a disorder or develop a platform. As we know recently, with the huge success of the COVID vaccine, that companies were able to start a vaccine program and bring it through the FDA approval and into the arms of millions of people in a very short period of time. Yeah. There has never been a vaccine that developed that fast before. So the companies usually, which is my job now, there is a lot of checks and balances to everything, which is great, because if you want to create a medicine, you want your work to be vetted and validated by you and by multiple people over your level of experience. Gotcha. So during the day, in my job now, I have a lot of meetings where I average at least each day I have a 2-hour meeting time, either with my team or with my supervisor, or a department meeting where you get to present your data, you get to discuss, or if you want to plan a new study, you get to like bring in the facts and decide how to conduct that study.
Gotcha.
The rest of the time is in the bench. So I have my project where I'm trying to lead to contribute to the company's goals.
Gotcha.
And the company, usually in companies, it's teams work, which is something I love. So you're not responsible for everything to create that molecule from start to finish. You are put in a position where your expertise makes the most sense.
Gotcha.
So that way, your time in the lab is used to the best way possible. So instead of spending hours and hours trying to troubleshoot something that you've never done before, there is someone who's already expert on this part. Where you just be like, hey, I did this part. This is what it looks like. Can you please finish it and give it to the next person?
Gotcha. So it's like an assembly line.
It's an assembly line almost.
Okay.
Yeah.
Okay.
Yeah.
And how long have you been in the certain position that you're in now doing that? Is that the
Almost
same
a year
research
and a
you were
half.
doing?
Yeah.
Is that the same research you were doing in grad school too? Is that the same practices and techniques? Or?
So the basics of the research, and that's another key thing. If you go to grad school, it's important to be in a lab where you get to learn techniques and not just be expert about that lab's research.
Okay.
So, for example, if you do your grad school working on, I don't know, let's say malaria. Okay, it's important that you learn the science of the disease and how to address it and what it is. But also, you need to learn some techniques. Because in the future, and again, it depends on the type of research that you want to do after.
Yeah.
If you want to open your own lab working on malaria, okay. But if you want to broaden your horizon and then go take a job to work on a different disorder, okay, try to learn from that research how to sequence DNA, how to handle cell culture. Do you need to work on in vivo disease model? How to identify the best disease model? All of these things you could learn to be able to transfer them to your next job. In my case, I took my current position within the same field, gene therapy, but it wasn't exactly the same topic. But I was still able to transfer some of the information that I got from grad school experience into this job. But now, obviously, you come to a new position. There are people who are experts because they are in the company more than you. So you have to be a sponge and learn from them.
That's what I was about to ask. Is like
exactly.
How do you guys exchange information? Because I remember you were saying like you guys are in teams, like an assembly line. Is there any time that somebody from another portion of the assembly line, either do they explicitly teach you, or do they do something and you watch them or you shadow them? How 100%. Does that cross pollination work?
You just. For one, you have to be open-minded. So, for example, you come to a company with your doctorate degree with a PhD. It's okay that you go to an RI, be like, hey, I've never done this. Can you help me? All of this, it should be a teamwork. Egos have to be put aside. Otherwise, you will not learn. The key thing is you will become expert at some point and you'll be able to teach people. But in the beginning, you have to be obviously not shy. You have to be ask questions. It's always better to ask the question twice rather than ask once and do it wrong and have to correct a mistake. And mistakes obviously happen, but it's better to be sure and be able to benefit from your own time. Do something once and do it correctly.
And that's one thing I do always think about is like that failure has to be part of the process.
Exactly.
Because I remember I had an after school program I used to work with called Day Lab, which is a great program using Lego to help teach kids. I'm pretty sure they're implicitly just teaching kids mathematics. Because I realized mathematics is just a map that you put on the world. It's literally how you understand. Because I remember working in the second grade classroom and they were talking about measuring things. I'm like, you got to do this for everything. Like absolutely everything you do as an adult. Anything you do, whether it's gauging how far a distance is, how long something's going to take you. And when I talking about financial literacy, it's budgeting. Like how much is it going to cost you to do? And even when I turn around and start doing real estate, I'm like, how much is this actually going to cost me? What is the timeline like? And it's one of the things I realize is one of the basic misunderstandings I see, especially with students. They just think, just do it and we'll figure it out. It's like, well, start taking some kind of data. And that's one seems to be a very much because the word is being tossed around technology so much, kids are really not understanding, like, data is just measuring, write down a number.
Right.
Write that number. And even when I start doing EBA, I absolutely love being able to compare one piece of data then to another and say, see, this is the change that we've made over the course of our implementation of this program or treatment.
Yeah.
So I'm actually really interested in finding out also the third part of our segment is what keeps you coming back to the lab? What keeps you engaged in the science that you're doing?
Yeah. I think the key thing with science, especially for someone like me who at some point in my life I wanted to be a physician, every day you think, or at least that's what I think for my job, is you think you will hopefully at some point help someone. And honestly, even if it is one person, there are a lot of, and again, my research is gene therapy. There are 7,000 genetic diseases that everybody around the world, in the US and hundreds of thousands of people have them and around the world that haven't been addressed. And this new revolution of genome engineering and gene therapy over the past 15, 20 years opened the huge doors to all of, and hope to all of these patients and their families to a cure. And maybe it sounds cheesy or no, but honestly, I think my hope, like one day in my life, which is what makes me come back to the lab every day, is to see something that I'm working on going into a patient and making some difference. You have to be passionate, obviously, about that. I'm the type of person, if I'm not passionate about anything, I'm not going to be able to succeed in it.
To stick with it.
And believe me, there comes days where they are hard, and be like, okay, is this the right job for me or no? But then there are these days that come after that are you get that piece of data that you're looking for, or you see your project was taken to this next step where to make everything worth it. And I think in research and in molecular research and medicine, there's so much time and space for improvement. We already made a lot of progress over the past several years, but in the beginning of this, we're talking about all of these technologies that are on the laptops, the size of your phone and everything. Imagine what all of this could be applied for in research and medicine. There are so many new instruments and so many new technologies, and scientists are going, as we were saying, to the atom and trying to understand how this tiny molecule is affecting a disease in this population, and how we can cure it. So all of this is honestly, I think, the golden age of research and medicine. There are so many things to do. Recently listened to a TED Talk by Melissa Moore, who is the Chief Scientific Officer of Moderna. And she was saying that because they had so much data about like mRNA and mRNA vaccine, they were able to design the mRNA vaccine in half an hour. That's crazy. Like to be able to have so much confidence in the science, to be able to put all of these pieces of data together, be like, you know what, this is what we'll go with. And this is exactly what many of us has now. I think that's the fascinating part. Obviously, I'm in biotech, and I think there are so many things even still to improve, especially access to all of these gene therapy drugs has to be controlled at some point, have to be more affordable to people. Obviously, all of these drugs are very expensive because the way that the research that was put into them, and especially because they take a lot of expertise to create and they're very delicate. Production is also very expensive, which makes the access to them is hard. There is obviously all of these ethical issues that have to be addressed to the different populations and like how we can make it accessible equally to people. And that is when, hopefully with time, the healthcare system in the country and whoever are make the decisions to be able to manage it and have it more accessible to everyone. Because that's the key. Otherwise, It's just going to be something in the vial that has no value.
So it's a context.
Exactly.
Can I get it to the people who need it?
Yeah. As a scientist, for people who are not in science now, for example, they know what mRNA is, which is very encouraging. Just for awareness, for scientific literacy, for everyone.
Right.
Because to me, mRNA and DNA and the protein is like the ABCs.
The ABCs for
so it's cool to hear, like, I don't know, my uncle or my dad, they know what mRNA is.
Yeah.
But in addition to that, and again, we were saying that there are all of these people with these genetic disorders that they're born with. Hopefully it will make them, or at least it make people understand what they are going through. Yeah. And then when they're hopefully at some of these gene therapy programs mature and they get to become a disorder, they become something common that people know about, because, we know about mRNA from the COVID vaccine.
Yeah.
RLNP from the COVID vaccine. Then people will become more comfortable with these type of new therapy programs that companies like mine and others are trying to develop to address disorders.
That's impressive, man. And just because I'm a killer for information. What is mRNA? Let us just would you be able to give us a definition? What is our mRNA exactly?
Yeah. So the mRNA and the step before it is the DNA, is the genetic information that basically makes us. Okay. So depending on the type of the order of these 4 DNA bases, A and a T, G and a C in your body, it determine what eye color you have, how tall you are, everything.
So those different combinations.
Different combinations, okay. Exactly. And it also, so from the DNA, you go to the next step, which is the messenger mRNA, where there is a protein that converts these DNA sequences into a message. That's why it's called mRNA or messenger RNA.
Okay.
This message gets read by another enzyme that converts this mRNA, which is again sequences of A and now U, G, and C into a protein.
Okay.
And the protein is what makes us. So there's a protein in your eye, there is protein in your hair, there is protein in your blood, there is protein in everything.
So the way that these bases are combined is what tells you, hey, express a blue eye, express a brown eye, express a green eye. Okay.
Correct, yeah. Okay. And then the people who have genetic disorder, they have a mistake in the DNA. So the DNA is not correct. Okay. So you're not going to correct they're not going to be able to make the correct mRNA. So they're not going to be able to make the correct protein.
So does that mean when the cell clones itself, it just perpetuates a mutated
Yeah.
gene?
So either it's a mutation that happened that they carried or it got passed on to them from their parents, or obviously some mutations happen by mistake of the DNA machinery, and that's when you get diseases like cancer or like any other diseases. So all of this information is what determine all of the downstream things that we have in our body, like as we said, like I told you, and eye color and hair color and all of these things.
Okay, and then one thing I did want to start adding to the show was explanation. Well, the mRNA, thank you very much for setting that clear, because I know a lot of people that I was speaking to, when they hear that, it changes your DNA. I'm like, hold on. Yeah, that misconception is very frightening because of however, whenever you go to the experts and they tell you and you still don't believe them, it's like, then what do you want? That's where it gets kind of, and that's really why I wanted to start shows like this, is to be like, hey, I can ask you specifically, this misconception is starting to spread very quickly.
Yeah,
so why not just
I think you're referencing the COVID vaccine misconception, because they think, they're delivering mRNA into your body is going to change. No, basically a virus like the COVID vaccine has a shell, and inside the shell there is the genetic information of the virus.
So another combination of A, G, T.
Exactly. Yeah. Okay. Obviously, when the virus infects people, the genetic information of the virus will get into you.
Okay.
But our immune system when a virus is inside us, what it can see the shell, because the shell is outside of the virus.
Yep.
The inside is what
The
genetic information that they can see.
Mm-hmm.
So whether it's a flu or any virus, a cold or chickenpox or COVID virus, the immune system will recognize the shell and try to make antibodies against the shell.
Okay, right. Just the shell.
Yeah. So what the scientists at the Pfizer and BioNTech and Moderna, they realized that we could make the immune system learn about the COVID vaccine by telling it what the shell of the virus look like.
Okay, so it's like giving the plans.
The plans, exactly. So, and not even the full shell of the virus. They gave it only that spike protein that you probably heard about in the news, which is just
how they attach to
part just part of the shell of the virus.
Mm-hmm.
So, because we know there are scientists who can learn what the sequence of the mRNA that makes the spike protein of the COVID virus.
Mm-hmm.
Be like, okay, if we take that mRNA sequence of the spike protein, if we give it to people, now inside your body, your cell, and that's it. Like you the mRNA vaccine role ends when you deliver the vaccine into the body. Now everything else is our body's job to create the vaccine, and that's what Melissa Moore was talking about in the TED Talk.
Okay.
Basically, your body will make, using the mRNA information of the spike protein, which it's just a spike protein, doesn't have any genetic material of the virus, doesn't have anything. It will make that spike protein inside you, and then your immune system will start making antibodies against the spike protein. Now, when you get COVID, actually get COVID after, because the virus still has a way to get into your body. If the your immune system had already learned that spike protein is a bad thing, so has already antibodies against it that will go bind to the COVID virus itself and render it inactive, or at least make you not as sick before the vaccine.
And would that be it attacking the spike protein specifically in that to keep it from
from attaching to the cell? Exactly.
Okay. And then there's one thing I did want to actually tell people, because I loved hearing this and it was really cool. What is wild type? What is a wild type? Because that just blew my mind when I was hearing that.
It's very catchy word. Basically, wild type means the normal. So if the wild type color of a flower is red, that's a wild type.
So that's just the naturally
that's
occurring.
a natural. Yeah, exactly.
Okay.
But if that flower has a mutation in the gene that makes the mRNA to make it red, the pigment red. So if they don't have that gene, that case the flower, let's say, will become white. So they call that flower mutated, let's say.
All right.
Yeah, but the wild type version is the red one, because it's the one that has the normal gene.
Okay, so wild type is more like the natural expression of what it's supposed to be, or what it's planned to be.
Yeah.
Okay, and then any mutation on that is just it removes the wild type.
Yeah,
and now it's just a mutation.
Yeah, and obviously there are like some versions, like that's why people have different eye color, and some has brown and has blue or green. Sometimes it's just a different version. It doesn't mean that if we don't share the same exact DNA sequence, it doesn't mean that yours is bad, mine is better. No, it just means there are different versions of it, as long as it's not pathogenic. So as long as these changes doesn't cause a disease, then it's fine.
It's just
doesn't make a
difference.
difference.
It's a mutation. It's like a benign mutation.
It's a different version of that DNA.
Thank you so much for listening. And I would love to have you guys check out my website and leave a message, or somebody whose job you're interested in. Please feel free to reach out to my Instagram profile, MISTER_L92, tutor with MRL.com, or Instagram. Thank you so much for listening, and don't forget, always chew your food.